Let me welcome you to the 6th lecture of NPTEL online certification course on network analysis for mines and mineral engineering. In this lecture, we will discuss about the critical path and its calculation procedure. Let us retrospect, like every lecture, retrospect what we have covered so far. Now, we know what is called job or activities. We know how the jobs are defined either in arrow diagram, activity on arrow diagram, or activity on node diagram. We also know what is called node, what is alternates. We know what is a dummy job, how the dummy jobs has to be assigned, how the dummy jobs has to be removed. Then we know what is redundancy, we know what is cycle, and we are also aware about the things that a cycle has to be completely eliminated, redundancy has to be removed for the smooth analysis of the network. So, now let us let us carry out some analysis on the network, and this analysis is called critical path method. So, we will analyze the criticality of a network for the possible optimization of the same. So, let us understand few more terminology here, what is path and what is critical path, because we have already discussed the term critical path method. Suppose for understanding this, let us define it now. Path is basically a sequence of activities that leads from the starting node to the finishing node, and critical path is the longest path in the network. That means, critical path is the path which takes the longest time from reaching starting from the starting node to reach to the finishing node is called critical path. To understanding more on this, let us just read this one. Critical path is the longest path which basically gives us the minimum time for the completion of the complete work. So, basically it is the longest path, but as it is the longest path, it allows all the path will be completed before the completion of this path. That is why critical path basically gives us the minimum time for completion of the total project, and the amount of slack, that means there is no relaxation time is available in the critical path, but in the other path some relaxation times are available. So, the path which is having 0 slack is also called a critical path. Let us understand this with a small example. This example I have taken again from the West and Levy's book. In this example, let us consider the similar example we have given in the introduction lecture of also, where we are starting from Ghaziabad to reaching at Delhi, but this example is telling that suppose two friends Allen and Becker are willing to move from San Francisco to Los Angeles, but Allen has to move through Santa Barbara and Becker has to move through Bakersfield. What is the reason? The reason is that Allen wished to have a meeting with his wife or have a lunch in his house at Santa Barbara where his wife is there, and Becker is willing to meet his friend at Bakersfield and may have a lunch there in the Bakersfield. The paths, that means their routes are different, the paths are different, and they have to meet at Los Angeles. So, consider they have started at San Francisco in the morning 8 a.m. and they are moving from San Francisco to Los Angeles, and consider that the Allen's required 8 hours driving, 8 hours driving to reach at Santa Barbara. He will take 2 hours at Santa Barbara to take lunch from his wife. Then from Santa Barbara he has to reach at Los Angeles with 3-hour driving time, where there is a fixed position in which Allen will meet Becker. However, Becker needs 5 hours to reach in the Becker field. He will also take 2 hours for a lunch with his friend or meeting with his friend. Then he will take 3 hours then he will take 3 hours from reaching Becker field to Los Angeles. So, that means starting at 8 a.m. Becker will reach at Becker field in 5 hours, that means 1 p.m. and he will spend there 2 hours, that means he will start from Becker field at 3 p.m. and will reach at Los Angeles at 6 p.m. Whereas, Allen takes 8 hours. So, from 8 a.m. he will reach here at 4 p.m. and he will take 2 hours for lunch etc. in his house. So, he will start at 6 p.m. from here and he will reach at this position at 9 p.m. So, the paths are different. First path, the Becker is taken will lead Becker at Los Angeles in 6 p.m. The second path which Allen has taken will allow the Allen to reach at Los Angeles in 9 p.m. and they have a meeting there. That means, though the Becker is reached at 6 p.m. in the Los Angeles, but Becker cannot attend the meeting. So, the meeting cannot be fixed at 6 p.m., but the meeting can be fixed at 9 p.m. only when the Allen will reach there. So, that means, though Becker will reach at 6 p.m., but the job, that is the meeting job which is required to be completed, that can be completed at 9 p.m. only. So, the path is showing us the completion of the network time is basically the Allen's path, not the Becker's path. So, Allen's path is the critical path which gives us the minimum time for the completion of the job if everything is well, but it also allows the slack to the other paths. That means, the other path is the Becker path, where it gives Becker a 3-hour slack. That means, Becker reaches at Los Angeles 6 p.m. That means, he is having 3 hours slack which he can spend anywhere as per his own wish. Instead of having a 2-hour lunch, he can have a 5-hour lunch there. Instead of starting here at 8 a.m., he can start at 11 a.m. also. So, all these slacks are available to Becker because his paths are shorter than the Allen's path. So, the path which is shorter is not the critical path. The path which is the longer path is the critical path, but the longer path is allowed the earliest completion of the job. That means, the meeting is the final target of the job. That meeting, earliest possible time to arrange that meeting is the 9 p.m. not the 6 p.m. So, basically this analysis reveals us that the most possible time for the earliest possible time for completion of the job is the 9 p.m. not the 6 p.m. So, this is called critical path analysis, and from this network you are able to understand that these are the paths, these are the paths, this is path 1, this is another path which is path 2. Similarly, there may be a number of paths available and we have to analyze each path and the longest path we have to find out, so that we can come out with the critical path. So, this analysis method is called critical path analysis. So, the same example is given here and you can see the network can be constructed like this, where job A is for the Allen to move from San Francisco to the Santa Barbara, and this is for the Baker, Los Angeles to Bakersfield. Then finally, a lunch in the both the places, finally in the lunch in the Bakersfield and in the in the Santa Barbara and in the Bakersfield, and then Santa Barbara to the Los Angeles. This is Bakersfield to Los Angeles. The same is depicted in this network, and you can find out the two paths, two available paths are 1, 2, 3, 6, 1, 4, 5, 6. The duration of the 1, 2, 3, 6, that is the node number, node 1, node 2, node 1 to node 2 to node 3 to node 6, that is the path 1, which takes a duration of 8 plus 2 10, 10 plus 3 13 hours, and there is another path from 1, 4, 5, 6, 1, 4, 5, 6, which takes 10 hours duration. So, this is the longest path, and this longest path is the critical path, which happens to be the Allen's path. So, clearly Allen's takes path 1 and reaches there at 13 hours. So, the earliest possible time of meeting is 9 p.m., which we have already discussed. So, again let us see the definitions of this. Path is basically a set of nodes connected by arrows, which begins at the initial node, that means the starting point of the complete network, and end at the terminal node of the network. So, starting point of the network and ending point of the networks are connected by the arrows, set of arrows is called path. A network may have n number of paths. The length of the path is the total time corresponding to the path, that is actually time is attribute here. It may be anything, it may be cost also, but in most of the cases we consider time as the main attribute in the critical path analysis. So, while we are considering the time as the attribute, so length of the path is the time of the total time corresponding to the path, that means which takes the time for reaching starting point to the ending point by the addition of the time or attributes assigned to each job. Critical path is the longest path in a project network, which takes the maximum time. A project network may have more than one critical path also. That means, in the previous example, if you see from San Francisco to Los Angeles, a person is taking from Santa Barbara, another is from Bakersfield. There may be another one, say someone they are driving, so they are taking the time for driving. Another person may have taken something, say he has gone to Seattle, and again Seattle to he is coming to Los Angeles, and he is flying instead of driving, and his time may be 2 hours for this flight. Then there is a 4 hours between the gap between two flights, another is the another 4 hours, which may take again I have to reach it 13 hours. So, let us consider there is a gap of 4 plus 2. So, this is a gap of 7 hours at this point. So, the flying time from San Francisco to Seattle is 2 hours, Seattle to Los Angeles is 4 hours, and 7 hours is the gap between two flights. So, that is why the time taken from this is also 13 hours, time taken from San Francisco to Santa Barbara and to Los Angeles is also driving time is 13 hours. So, both the paths are taking 13 hours, that means both the paths are critical path. So, there may be more than one critical path. The activities or jobs on any critical path are called critical job or critical activities, because the most importance would be given to them, because they do not have the slack. So, that is why the critical paths are important, and more man, machineries, money has to be invested on the critical paths, jobs of the critical paths, so that they can be completed early, otherwise the complete project will be deferred. So, let us consider an example. This is the example, I have not given you the table. In this example, you can see the nodes are only connected with the jobs names are also not given, only the attributes. Say for this consideration, this is hour say. Okay. So, the time of these are given, and you can see the path A is taking this one, that means 1258 node is the path A. The path B is this one 1358. So, this is path B, and if you see the time required for completion of path A is 2 plus 3 plus 4, that means 9 hours. Path B time is 4 plus 5 plus 4, that means it is taking 13 hours. The path C is 1367. So, path 3 1 3 6 7 8. So, this path 3 is taking 4 plus 5 plus 6 plus 1. So, 4 plus 5 9, 9 plus 6 15, 15 plus 1, path C is taking 16 hours. Then let us consider path D, which is 1 3, then 4, then 6, then 7 and then 8. So, this is the path D, which takes 4 plus 2 6, 6 plus 2 8, 8 plus 6 14, 14 plus 1 15. So, this takes 15 hours. Then finally, the path E, which is 4 1 3 4 7 8. So, this is path E, this is 4 plus 2 6, 6 plus 3 9, 9 plus 1 10. So, that means path A is taking 9 hours, path B is taking 13 hours, path C is taking 16 hours, path D is taking 15 hours and path E is taking 10 hours. So, there are 5 paths in this network, and if we look into these paths, the activities connected to each path is taking in different way. A path is taking 9, B is 13. So, A is the smallest path taking 9 hours and C is the largest path taking 16 hours. That means, this is the critical path is the C path, and this gives us that C path, which is 1 3 6 7 8. This path is the critical path, and this requires the earnest attention of the management for the possible completion of its on time. That means, to complete this total project, it requires at least 16 hours for the completion of the project, while it attributes a 7 hour slack in the A path, it attributes a 3 hour slack in the B part, 1 hour slack in the D part and 6 hour slack in the E part. So, basically critical path is very important, which shows one or a number of paths which are coming to the critical path needs maximum attention, that has to be completed at the earliest, where The other parts are having some slack time, which can be utilized in a judicial manner while the planning or optimization is being carried out. So, basically critical path is giving us the analysis from where we can infer which path has to be taken care more. We can carry out analysis of critical path for activity on node diagram also. Say this is the case for the Allen's and Becker's movement starting from the San Francisco to Los Angeles. So, in this case this is the Allen's path, this is the Allen's path which takes the this is the movement time from San Francisco to Santa Barbara, this is the lunch time and this is the Santa Barbara to Los Angeles time. Similarly, this is the Becker's path which is the driving time from San Francisco to Bakersfield. This is the lunch time at Bakersfield and this is the Bakersfield to Los Angeles time. So, in this case we say the path 1 is we have not mentioned here is A, B, C path which takes 13 hours. Path 2, this is path 1, this is path 2 which is basically D, E, F route which takes 10 hours. So, similar way you can carry out it in the activity on node diagram also. However, the construction of network in the computer in activity on node diagram is little bit difficult. So, you can see this way you can calculate, which is already discussed to you. So, in any case we can have a multiple critical path also. Say in this case, suppose we rearrange the table a little bit for the previous example which we have discussed, and you can see in this case we are having path 1, this is 1, 2, 5, 8, 9 and the total time required is 2 plus 5 plus 3 plus 5. So, it is coming 15 hours. The second path is 1, 3, 5, 8, 9. So, 1, 3, 5, 8, 9 that is 3 plus 4 plus 3 plus 5. So, 3 plus 4 7, 7 plus 3 10, 10 plus 5 15. Let us consider this third path 1, 3, 6, 7, 8, 9. So, this is 3 plus 3 plus 2 plus 2 plus 5. So, 3 plus 3 6, 6 plus 4 10, 10 plus 5 15. So, this is 15. We can have the D path 1, 3, 4, 6, 7, 8, 9. So, this is 3 plus 2 plus 1 plus 2 plus 2 plus 5. So, 3 plus 2 5, 6, 7, 8, 9, 10, 15. So, again it is coming 15 the total length, and if you see the last one E path 1, 3, 4, 7, 8, 5. So, this is 3 plus 2 plus 3 plus 2 plus 5, that means 3 plus 2 5, 5 plus 5 10, 10 plus 5 15. So, all the paths are now coming 15. So, that means all the paths are critical now, and we have to give the intense care about the optimization of all these works. But probably you can wonder how it is possible. Actually, this is possible because of our previous example. You can see in the previous the similar problem where we had the 16 one is the maximum one and the others the smaller one is of 9 hour length. The maximum was actually let me write all the path durations here which we are discussed in this earlier case. In earlier case, these durations were 9 here, it was 13, this was 16 and this was 15 and this was 10. Now, in earlier case when we had this one, what the management did? The management found that the demand allow us for a length of 15, which is appreciable for the management. So, considering that, they change the man, machine, material and money requirement in every jobs. By changing that one, what they did, say suppose they reduce the manpower in some job at this position or in that this position they did earlier in the network, and by doing that they lengthen this path to the 15 hour and reduce the cost of the production for this path, and they invest additionally in the critical path, in that means that C, which was taking 16, but the additional investment in terms of man, machine, material etc., allow them to shorten the path to a 15 hours, and that is allowing them to address the target time of 15 hour of the completion of the complete network. So, suppose let us consider this is the manufacturing of TV. Okay. Say consider this is the power board, this is the display board, this is the sound box, this is the picture, this is the screen and this is the cabinets etc. Say let us consider like this, these are the way we are carrying out. So, that means putting some additional man machine in the screen part allow us to complete in 15 hours instead of 16 hours, and we reduce the requirement of man, machine etc. in the other path. So, we are providing a little bit additional, we are actually saving some amount or money on the costing of this one. So, basically we are achieving the production target of 15 hours and we are able to complete this, and the costing is now acceptable to us. So, this was when we have carried out it with a natural costing which we have planned initially. Then with the analysis of the critical path, we are able to come out with the decision in which we need additional manpower, man machines, in which we can withdraw some man machines, additional manpower, excess manpower provided in that. So, some length may be extended, some length may be shortened to achieve the target date and to achieve the required costing in these networks. So, we are having multiple critical path here, and this forces us that to give the maximum importance to all those cases. So, basically from previous one to this one allow us to come out with this by shortening these points in different steps by providing additional withdrawing the manpower or providing the additional machines etc. Basically, what how this type of analysis will be carried out, we will discuss this in our subsequent lectures, so that you can carry out this type of practices in your future. So, this is more or less end of this lecture. So, I hope in this lecture you are able to analyze the different paths of a network, and you can come out with the which one is the critical path or which are the critical paths in a network, and based on that the managerial people can take the decision where the additional investment or the additional manpower requirement can be provided. So, I hope after viewing this lecture you carry out some analysis, you will solve n number of critical path network problems are provided. You will search out and find out what are the paths. I always mention you must first find out what are the paths, available paths, find out all the available paths, then find out the length of those paths, then find out what is the critical path. So, by this way you go for exercising in your house, that will instill confidence in you. Thank you.